Okay, so we are live now, and I'm going to try and solve the following paper that's appearing on the screen. Uh, Let me just check the stream for a second. Okay, now let's start with this paper. Uh, you can see over here. Hopefully, you can see on the screen. It's an October-November 2019 paper, which is the latest one, 5070. The theory paper, the structured question paper, and this is O levels chemistry. That's the paper that's coming up. So starting with the first question. The first question is on your screen. Now, starting with the first question, the question reads that the diagram shows part of the periodic table. So I've over here, I have a periodic table that's in front of me. So which part are they exactly showing? These are the noble gases over here. So they're showing the noble gases. Then it's group 7. So it's the right hand side. Now answer the question using only the elements shown in the diagram. Each element may be used once, more than once, or not at all. Write the symbol for an element which, so we have to answer these questions now. So which element forms an X2 minus ion? That is group 6. Any element from group 6, it needs 2 electrons. So it's a group 6 element. Let me number the group numbers over here. This is group 7. This one is group 6. This is, these elements are from group 5. And then you have your group 4 and so on. These are group 3, and these are your noble gases at the end. So group 6 elements, so any one of these would be the correct answer. So I'm going to take oxygen over here. Then the next part is a light green gas at room temperature. You must know this, that this is chlorine gas. Forms an ion which gives a yellow precipitate on addition with aqueous silver nitrate. Now, these are your tests for anions. Aqueous silver nitrate is a test, and let me briefly describe. It's a test for 3 ions. One is Cl minus one. Then you have your Br minus one ions, and there's a third halide ion which is I minus one. So silver nitrate is a test for all three. The first one has a white precipitate with silver nitrate. The second one has a cream precipitate, and I minus one has a yellow precipitate, and that's what we are looking for. That it forms an ion which gives a yellow precipitate on addition to silver nitrate. So that's iodine. And if you have a look, that is definitely given in the table above. Next one is used to make food containers. So food containers are supposed to be unreactive. They're made from unreactive elements. Aluminium is one. Tin, there is no tin over here. Tin is also lots of food cans, etc., are made from tin as well. So I'm going to go with aluminium. Aluminium is a good food container. Your lots of containers are made from aluminium. Your pots, pans, etc., are made from aluminium. It's an unreactive metal, so it's used to make food containers. You can open a marking scheme. Maybe some of the answers that I give over here, they might not be the correct ones. You I might lose 1 or 2 marks here and there. I haven't opened a marking scheme right now with me, so I'm not actually checking the answers. As aluminium, just a brief description. Aluminium is a pretty good food. It's a very good food container because it's a very good conductor of heat and electricity. It loses 3 electrons. Plus, it's very unreactive as well because of the oxide layer. If you remember, aluminium has a coating of aluminium oxide which is non-porous and unreactive. So the food at high temperatures is not going to react with the aluminium. Next one is a diatomic gas which forms 78% of dry air. You must know this is nitrogen gas. So that's Air is composed of mainly two things. 21% is oxygen, 78% is dry air. Let's move to the next part of the question and just wait 1 minute. Now, this part of the question is it states that magnesium is a metal and state two properties which are characteristics of most metals. Number one, they're malleable and ductile. And they conduct electricity. They have free moving electrons. So those are the two properties. I'm also going to just quickly describe what metallic structure looks like. Metals, they all like to lose electrons. So if you have a bunch of metal atoms in a structure like iron, all the metal atoms, they like to lose electrons. So they would end up forming these positive ions. So there would be lots and lots of positive ions being formed because they like to lose electrons. But where would the electrons go? They have no place to go. No one is gaining electrons. So those electrons are just roaming around. And they're acting as a glue that is keeping the structure together because electrons are negatively charged. And the negatively charged electrons would be attracting the positive ions. So the gaps are filled with these negatively charged electrons, which are negatively charged, and they're attracting the positive ions. So they're acting as a glue that's keeping the entire structure. So they're pretty strong, but they're malleable, which means that if you apply a force, like for example, if you hammer them, the ions would slide over one another and they're going to conduct electricity because they have free moving electrons. The next part, part B of the question, is complete the electronic structure of a magnesium atom showing all electrons. You don't even have to, I'll just give you the symbol of magnesium atom. It's Mg, 12 and 24. So it has a total of 12 electrons. And he's talking about the atom. So it's 12 electrons would be 2, 8 in the second one. And you're left with just 2 electrons in the outermost shell. So that's a total of 12 electrons. Next one is magnesium reacts with bromine to form magnesium bromide. Magnesium bromide is an ionic solid at room temperature. Explain in terms of movement of electrons how magnesium bromide is formed by the reaction of magnesium with bromine. So it's a 3-mark question. Now I'm going to do the dot and cross diagram. I can actually we can have the dot and cross diagram over here. I'm going to draw the atom of bromine. So let's say this over here is the outer shell of bromine, just the outer shell. Now bromine, I'm not going to draw all the shells. Bromine is a big atom. It's going to take a long time, and they haven't even asked us to draw the outer shell. So I'm going to draw the outer shell of bromine. Bromine is in group 7, so it has a total of 7 valence electrons. It needs 1. Magnesium is going to, it's a metal, and a metal loses its outer electrons to get a complete octet. Bromine, on the other hand, gains electrons. So bromine, on the other hand, would gain. It's going to try and gain electron. It's a non-metal. Anyway, so you have magnesium, which would end up losing 2 electrons. So these 2 electrons are lost. So it exactly loses 2 electrons and gets a positive 2 charge. But bromine, on the other hand, has only room for 1 electron. So that 1 electron is gained by this bromine, and it gets a negative 1 charge because it's only gaining 1 electron. It gains exactly 1 electron. So it gains exactly 1 electron. Now the thing is, there should be 2 bromines over here. Why? Because magnesium was losing 2 electrons. So the outer shell 2 electrons are lost. Bromine was only gaining 1 electron. So there have to be 2 bromines. Otherwise, where would the other electron go? So 1 electron is gained by 1 bromine. The other electron is gained by the other bromine. So we're going to describe all of that. This part of the question was all about describing how the ionic bond is formed. So explain in terms of movement of electrons. So the first part is the movement of electrons, and I'm going to state that magnesium loses 2 electrons. Uh, Bromine gains 1 electron. So there should be 2 bromines. So there should be 2 bromines, and then they would be able to gain the 2 electrons lost by magnesium. So, and then they would be able to gain 2 electrons lost by Mg. I'm also going to write the charge. Mg loses 2 electrons, gets forms a +2 ion. Bromine gains 1 electron, forms -1 ion. Anyways, that's how magnesium bromide is formed from the reaction. So we pretty much described everything that was happening over here in this dot and cross diagram. Remember to it's preferably write your answers in points. It's much better than writing in essay form. Next part is magnesium bromide is soluble in water. So just one of the physical property of magnesium bromide. Now all ionic compounds they also have high melting and boiling points. Why? Because uh, in an ionic lattice, what happens is that the structure looks like this. There's positive ion attracting a negative ion, which is then attracting a positive ion, which is then again attracting a negative ion, and so the structure just continues in all directions in 3 dimensions. So the positive and negative ions, they all attract each other very strongly. So they have high melting and boiling points. And the melting and boiling points would be higher if the charges are greater. If the ions have greater charges, there's going to be more attraction. So the ionic lattice would be much stronger. Sometimes the ionic lattice is very strong. For example, substances like aluminium oxide, where aluminium is +3 and oxygen is -2, the positive and negative ions would attract each other very strongly. Or magnesium oxide, where Mg is +2, oxygen is -2, so the attraction is a lot stronger. But then there are other ionic lattices which are not as strong. So if the charges are greater, then the ions would attract each other with a lot of strength. And they're going to have high melting and boiling points. Reduce the products formed at the anode and cathode when concentrated aqueous magnesium bromide is electrolyzed. And you have to write down, you have to do electrolysis over here of concentrated aqueous magnesium bromide. So I'm going to quickly draw a diagram for electrolysis. Let's do it as quickly as possible. Uh, Assuming that this is the electrolysis is for an inert electrode. So here's your battery in the middle. So we have made the diagram. This side is your cathode. This is your negative side, it's your cathode. And this side is your anode, it's the positive side. Now the solution has magnesium, bromide, Mg2 plus, and Br -1, and it's concentrated as well. There would be 2 ions as well because aqueous, so H+1 and OH -1. The reason I've written the positive ions over here is that the negative cathode is going to attract the positive ions. On the other side, the positive anode is going to attract the negative ions. So the ions separate. They go in different directions. Positive ions at cathode, negative ions at anode. What are the products now at cathode and anode? What's going to happen is the battery would be sending in electrons at cathode. Now, someone out of these two is going to gain electrons. And how do you figure out who's going to gain electrons? You look at the reactivity series. The electrons could either be gained by Mg2 plus, or they could be gained by H+1. So battery is sending in electrons, and one of the two is the one that's going to gain electrons. So I'm going to quickly, very quickly, I'm just going to Google the reactivity series. So that's in front of us. So if you have a look at the reactivity series, and let me open this reactivity series over here, you would notice that magnesium is over here, and there is hydrogen which is right over here. If you can see my pointer, it's magnesium and hydrogen. So the competition is between them, whether magnesium gains electrons or hydrogen gains electrons. So remember the rule in electrolysis, it's always the lower one that ends up gaining electrons. So it's hydrogen that has a stronger tendency to gain electrons. So out of these two, the battery is sending in electrons. The electrons are not going to be gained by, I'm going to put a cross over there. They're not going to be gained by magnesium. It's going to be hydrogen that ends up gaining electrons. And hydrogen is diatomic, so it has to be, you have to double that. So it's going to be 2H plus 1 gaining 2 electrons to form H2 gas. A diatomic molecule would be formed. On the other side, let's move to the other side now. Now, someone out of these two, the positive side of the battery is trying to gain electrons. So it's pulling electrons away from Br minus 1 or OH minus 1. So one of them would be the one that would be losing electrons. So it could either be Br minus 1 or it could be OH minus 1. And there's another reactivity series that's over here, which starts with I minus 1, then Br minus 1, then OH minus 1. Then you have Cl minus 1, and so on. So there's another reactivity series which you need to remember. And in that as well, the one that's lower in the reactivity series is the one that loses electrons, which in this case is going to be Br minus 1. Not It's not going to be OH minus 1. So Br minus 1, and Br minus 1 group 7 is also diatomic, so it's going to be 2 Br minus 1. It would end up losing electrons to form a Br2 molecule, and it would loses 2 electrons. So I've gotten the products at cathode and anode now. At cathode, it's going to be hydrogen gas. So product at cathode is hydrogen, and the product at anode is going to be bromine. And also remember that in a lot of books and even online, in a lot of places, this series is written incorrectly. Remember, the correct order is I minus 1, that has the highest tendency to lose electrons, then Br minus 1, OH minus 1, Cl minus 1. And the rest of the ions, nitrates, carbonates, sulfates, phosphates, they would come up over here. I'm not going to write them because their turn never comes. It's always an ion that's lower in the reactivity series that always loses electrons. So we don't need to even remember the complete series, just the start. That should be enough. And remember, for Cl minus 1, if it's concentrated, then electrons would always be lost by Cl minus 1. Now just wait 1 minute. Now let's move to the next part, which states part E. Part E states chlorine reacts with aqueous magnesium bromide. The products are aqueous magnesium chloride and aqueous bromine. Construct the ionic equation for the reaction. So for this, I'm going to first construct the equation. So they're saying magnesium bromide. They've actually given you everything. Reacts with chlorine. Now, chlorine is more reactive. Remember, in group 7, the elements that are higher up in the reactivity series are the ones that are more reactive. So chlorine is more reactive. It's going to knock out bromine, and it would end up forming magnesium chloride. And what's going to happen? Bromine is going to be produced, diatomic. Now, how do you write the ionic equation? Let's rub this off. This is the equation that's already been mentioned over here. Products are aqueous magnesium chloride, so it's MgCl2 and bromine. Anyways, how do you write the ionic equation? When you're writing ionic equation, what happens is that if an ion is aqueous and if it's ionic, then you dissociate them into their ions. Ionic compounds, the ions scatter. So magnesium bromide would be the Mg ions and the Br ions would scatter in the solution if it's aqueous, and it's being reacted with chlorine. The products are MgCl2 that's formed, so Mg2 plus ions and two Cl ions, they would be scattered in water, and you're going to have Br2 that's going to be displaced. Anyways, and you're going to remove the spectator ions. Spectator ions are the ones that don't do anything in the reaction. So Mg2 plus, it's appearing in the reactants as well as in the products. So that means it's not taking part in the reaction. So any equation without the spectator ions is your ionic equation, which in this case would be 2Br minus 1 plus Cl2, and it would form 2Cl minus 1 and a Br2 molecule. So that is going to be your equation. So remember the process of writing an ionic equation. Uh, Dissociate any compound that is ionic and soluble. So I dissociated these two compounds. In aqueous solution, Mg ions and Br ions would be separate. They would be in aqueous state and they would be dissociated. They would be scattered all over in the water. MgCl2 is also aqueous, so its ions are scattered. The reason I did not do anything with Cl2 is because it's a covalent molecule. Br2 is also a covalent molecule, so it doesn't form ions and it doesn't dissociate. Now, so we have written down the ionic equation. The next part is explain why aqueous magnesium chloride does not react with aqueous bromine. So why doesn't it react? Because bromine is less reactive. So bromine is less reactive than chlorine, so no displacement is going to take place. The next part of the question number 3, is petroleum crude oil is a mixture of hydrocarbons. Describe and explain how petroleum is separated into different hydrocarbon fractions. In your answer, include a description of fractional distillation in an oil refinery. You may draw a labeled diagram. So how many marks is this? This is a 3-mark question. So we can actually come up with a label diagram. What's the label diagram? That it's going to show a chimney, and there would be vaporized gases would be coming into this chamber. So it's vaporized crude oil that's entering this chamber at high temperatures. So this has been heated to very, very high temperatures. So vaporized crude oil is coming in, and there are going to be trays over here in this. So lots and lots of trays that would be collecting anything that's condensing. So you have all these trays. Um, so the vapor starts to rise up. At the bottom, the substances that have high melting and boiling points, they condense. And those are basically the ones that have large molecules. So substances that have very large molecules, they're going to condense at the bottom. Uh, and substances that are smaller in size and have low melting and boiling points. Remember, in organic chemistry, the bigger the molecule, the bigger would be the melting and boiling point. So anything that has low melting and boiling point, they're basically small molecules. They are going to condense a lot later. So at the bottom there's high temperature, and as the vapor rises, it cools down. So the vapor would rise and it would cool down. Now you have to explain how how petroleum is separated into different hydrocarbon fractions. So I'm going to briefly describe the process. Vaporized crude oil is passed through the fractionating column. So that's your fractionating column that I drew. Remember to use this word. Where it cools down as it rises. Different fractions. So different fractions have different boiling points. So remember to mention this as well when you're talking or describing fractional distillation or fractionating columns, because fractional distillation works because particles or substances have different boiling points. So different fractions have different boiling points. So higher boiling point fractions are collected earlier in trays. Condense early, and are collected in trays. Lower boiling point fractions they are collected much later, or they are collected at higher positions in the whole thing in the fractionating column. Anyways, we've written a much longer answer than what is required. So and let me open the marking scheme as well, just to compare these big questions, how they should be answered. I said, just hold on 1 second. Let me quickly. This is 5070 and W19. Let me quickly open the marking scheme as well to figure out how the marks are distributed. Always remember to consult the marking scheme, especially when you are having trouble. Like in this question, I'm having trouble how to figure out how the marks, because it was a very general question. I mean, the problem is always with general questions, that when you get these general type of questions where it's too descriptive, then you're not very sure how the marks are going to be distributed. So I have the marking scheme in front of me now. Uh, Now you had to describe fractional distillation of crude oil, so it was a very general, open-ended question. You could have written pages on this. So it was just a 3-mark question. So I've opened the marking scheme now, and if you look over here, uh, you would notice that, and this over here, they're mentioning everything over here. So the idea that petroleum is vaporized, we did mention that. Uh, the idea that petroleum enters near bottom of the column. So we had this chamber, and the petroleum, vaporized petroleum, was entering at the bottom. So that's also correct. So we've gotten 2 marks, and see how open-ended the question is. They've given you 7 or 8 points for just a 3-mark question. You could have written anything to get 3 marks for this. Temperatures high at the bottom, low at the top. Idea of a column, that even gets you 1 mark. Larger hydrocarbons have higher boiling points. So we wrote pretty much, we wrote an 8-mark answer. They were just looking for 3 marks. So it was a very open-ended question. So remember, whenever you get an open-ended question where you can write a lot, uh, then even the marking scheme would be helpful to you. It's going to give you lots of options to choose from. Uh, it's just 3 marks. You needed any three of the points, and you would have been, and that would have been fine. But in your paper, make sure that you play on the safe side. If it's an open-ended question, write 5 points. If it's a 3 mark question, write 5 points. Even if you can write pages. Anyways, next part of the question is state one use for each of these hydrocarbon fractions. Kerosene. Kerosene is airplane fuel. Then you have naphtha. Naphtha is feedstock in chemical industry. So a lot of your raw materials, your medicine industry, pharmaceuticals, they depend on naphtha as a feedstock, as a raw material. Next part is the refinery gas fraction contains methane, ethane, and propane. To which homologous series do these hydrocarbons belong? Now that's an easy one. It's ane, and ane. So that's an alkane. Give the general formula for the homologous series which contains methane. So he's basically asking for the general formula of an alkane homologous series. What were the alkane homologous series? They were those series which were saturated hydrocarbons. They only contained carbon and hydrogen atoms, and all of them had single bonds. So each carbon makes 4 bonds in total. So they would just be hydrogens making single bonds with each one of the carbon atoms. This is an example of propane molecule. The next part is the exhaust from diesel engines contain carbon monoxide, which is very poisonous. Explain how carbon monoxide is formed in the diesel engine. Due to lack of oxygen, incomplete combustion. So, incomplete combustion, insufficient supply of oxygen, or lack of oxygen. That should cover it. Describe one effect of carbon monoxide on human health. Causes choking. It's a poisonous gas. So it's a very poisonous gas. It causes choking. Why does it cause choking? Because it attaches to hemoglobin, your heme group in your red blood cells. It attaches to it, and irreversibly attaches to it. Now, the purpose of the hemoglobin was to carry oxygen. So if the hemoglobin gets connected to carbon monoxide, it's not able to carry oxygen. And if it's not able to carry oxygen, then your cells, etc., are not going to get oxygen. So just hold on 1 minute. Let's move to the next part. Now let's move to question number 4. Some of you are asking which paper. I mean, this is a whole paper that we are trying to solve. So it covers almost every topic. Now this question, probably related to acid, bases, and salts. Preparation of salts, maybe preparation of salts. Actually, it's a rate of reaction question. Now the equation shows the reaction of calcium carbonate with hydrochloric acid. So it's a calcium carbonate, a piece of chalk in acid, producing a salt, carbon dioxide, and a water molecule. Now, the rate of this reaction can be determined by measuring the decrease in mass of the reaction mixture. Describe one other method of following the progress of this reaction. So, just a quick recap about rate. What is rate? What do you mean when you talk about rate of reaction? So, what is rate? Now, remember, whenever someone is talking about rate, what they're basically talking about is how fast is the change happening with respect to time. Now, this change over here could be anything. It could be a color change, it could be bubbles of gas, it could be any change of gas being produced, mass being decreased. So, this change could be anything. You just have to measure how fast that change is happening. Now, in this reaction, if you look at this reaction, there are a couple of things that are changing in this reaction. One is that the mass is decreasing, and I'm going to explain why the mass is decreasing, because if you have HCl, so if you have hydrochloric acid and you added a piece of chalk in it, calcium carbonate, that's been added over here. What's going to happen is, if you can see over here, this carbon dioxide gas that's being produced, CO2 gas. If CO2 gas is produced, you're going to immediately see these bubbles forming. And where would the CO2 gas go? It would be, it would just simply go into the air, into the atmosphere. And if CO2 is lost, mass decreases. So mass is decreasing. Why? Because CO2 is constantly being lost. So the amount of reactants, whatever things are present in the solution, they decrease because the carbons and the oxygens, they escape into the atmosphere. So obviously the mass decreases. So he's measuring the rate or speed with which the mass is decreasing. So what are the other methods that you could follow? So what you could do is you could measure the volume of CO2. I mean, that's changing as well. That's one thing that you could do with respect to time. WRT with respect to time. So measure the volume of CO2 that's being produced. So describe one other method. So measure volume of CO2. And how can you measure the volume of CO2? You can put a gas syringe by collecting CO2 gas in a gas syringe. In a gas syringe. And once you collect that by collecting it in a gas syringe, once you do that, uh, describe another method. Plot. I'm not sure if this is required. Maybe I'm going into a bit more details. Plot graph, and just hold on 1 minute. So my board just hung up by collecting CO2. Let me rewrite this. So measure volume of CO2 by collecting CO2 gas in gas syringe. And you can plot a graph. Plot a graph of volume of CO2 collected. So plot a graph of volume of CO2 collected with respect to against time. So the time axis would also tell you how quickly that CO2 gas is being collected. Next part is describe and explain using ideas about collisions between particles, how the rate of reaction changes when the same mass of calcium carbonate is used in smaller pieces. So previously, let's assume that it's a big chunk. This is calcium carbonate. Now, if you're using a big chunk of calcium carbonate, what would happen is that the surface area would be lesser because HCl, let's say this is calcium carbonate and HCl is reacting from the outside. So the HCl would only react with the particles that are on the surface. It can't react with the particles that are inside. I mean, if there's particles that are inside, it can't react with those particles. Uh, so if you break this into tinier pieces and you crush it and you make it powdered or break it into tinier pieces, now the thing would be that more particles, the surface area has increased. HCl is going to surround each of the particle and it would react from all directions. Now, more particles would be able to take part in the reaction and they would be able to collide with those with particles from HCl. So just hold on 1 second. My board is again. So I'm going to write over here. So more particles. Now this clearly shows. Just hold on 1 second. My board is hanging up. Now, more particles would be able to collide with smaller particles. So the surface area is going to be greater. So smaller particles, they have more surface area. And if they have a greater surface area, that indicates more frequent collisions would happen. So more frequent collisions will happen. So, and which is why the rate of reaction would be faster. Over here, the whole problem is that the particles that are inside, only the surface particles would be reacting if it's in a bigger chunk. The inner particles would not be able to react. Part C is describe and explain using ideas about collisions between particles, how the rate of reaction changes when the temperatures increase. All other conditions stayed the same. So again, it's ideas about collisions. So the particles will have more kinetic energy. Always use that word. So if they have more kinetic energy, they're going to travel faster. So you're going to have not only more frequent collisions, because they're traveling faster, they're going to bump into each other more. And they because they have more energy, they're going to bump into each other with more speed as well. So percentage of successful collisions also increases. So now the collisions would be more successful as well because they would be more energetic. So percentage of successful collisions also increases. Anyways, we can check both of our answers with the marking scheme that's given. Uh, so particles move faster, they have more kinetic energy, that gives you 1 mark. So and also more successful collisions, so that's also 1 mark. Uh, and the first one was only the frequency of collisions were higher. Greater number of particles exposed, rate is faster. So the surface area is greater. That's this statement over here. I wrote more surface area. So greater number of particles exposed, that pretty much is the same thing. Let's go back, have a look at the next part, which is a moles part. Calculate the minimum mass of calcium carbonate in grams needed to produce 16.8 cm3 of carbon dioxide at room temperature and pressure. Give your answer to 3 significant figures. So let's find the moles of carbon dioxide first. What's the formula of what's the formula for gases? It's the volume of gas, which is 16.8 cm cube, divided by the molar volume. Since it's cm cube, I'm going to keep everything in cm cube. So 24,000 cm cube. Let's open our calculator. It's going to be 16.8 divided by 24,000. So 16.8 divided by 24, 1, 2, 3. And the answer I'm getting is exactly 0.0007. So it's 0.0007 moles of what? Moles of CO2. So we found the moles of CO2. But that's not what they're looking for. They're looking for the mass of calcium carbonate. So go back and look at the equation that they gave us. So here's our equation. I have found this part. I found this to be 0.0007 moles of carbon dioxide. Now, the ratio in the equation is 1:1. So the amount of moles of calcium carbonate would be exactly the same. It's going to be 0.0007 moles. Because it's 1:1. One molecule produces 1 molecule of carbon dioxide. So it's going to be 0.0007 moles as well. So let's head back to our moles part. So the moles of calcium carbonate are going to be equal to the moles of carbon dioxide because the ratio is the same. So it's 0.0007 moles. What do we do next? They were asking for the minimum mass. So if they're asking for the mass, what's the formula for mass? Mass is moles multiplied by mR. So we know the moles of calcium carbonate, it's 0.0007, and the mR of calcium carbonate is, calcium is 40 in the periodic table, carbon is 12, oxygen is 16 times 3. So this over here is your mR of calcium carbonate, which is 100 actually. If you add this up, 40 plus 12, that's 40 plus 12 is 52, plus 16 into 3 is 48. So it's 0.0007. So let's open our calculator again. It's going to be 0.0007, and I'm going to multiply it by 100, which is the mR, and I get 0.07 grams. So the answer would be 0.07 grams. So let's also quickly check our answer. It's 0.07 grams. Now, one mistake that I've even made over here is that make sure that you write answers to three significant figures. Now, three significant figures is that starting from the first, I mean, this one is written incorrectly. It should have been 0.07 grams. Now, this is one significant figure. Now, make it three significant figure. I'm going to add two more zeros. Remember, even if the value is followed by zeros, even this number is incorrect. It has to be three significant figures. This value over here is just one significant figure. Add two more zeros to make it equal to three significant figures. Make sure that you, especially for O levels, make sure that you write answers up to three significant figures. 0.07 is not sufficient. It should be 0.07 followed by two more zeros. Next one is describe a test for carbon dioxide. Now this test over here is lime water or bubble through lime water. Observation would be it turns milky. So that is the observation. Next one is calcium hydroxide can be used to control the pH of the soil. Explain how calcium hydroxide controls the pH of the soil. So right in, it's a base. First thing, calcium hydroxide is basic. Metal hydroxides are bases. And give an equation, simply give an equation. It reacts with an acid to produce and neutralizes it. Basically, if this is the acid, it's the acid in the soil due to acid rain, probably acid rain. H plus 1 ions, calcium hydroxide produces OH ions. Those OH ions react with H plus 1 and they get neutralized to water. And what's left is calcium 2 plus. So that's your equation. If you give an equation, equation is the best description for anything. You don't even have to write words for that. And let's see if I have still energy left for doing question number 5. Just give me 1 minute. Somebody was asking if we can use water displacement method for carbon dioxide. You can't. Carbon dioxide is kind of slightly soluble. So water displacement or collection over water, that can't be used because simply because it might dissolve in water. Anyways, let's start doing question number 5. The table shows some properties of 4 group 1 elements. You're given, so what are they talking? Complete the table by estimating the melting points of sodium. So we're just going to follow the trends. Nothing special here. And it's just estimating. You don't need to use a calculator, just estimate. Lithium 181, potassium 63, and then rubidium. So it's decreasing. So my best hunch would be somewhere in between. So let's make it 120. That kind of looks reasonable. And they're also talking about atomic radius of rubidium. Rubidium is over here. So the radius is slightly, this is 15, 19, 23. So I think it's increasing by 4, 5, 9, 23. So let's make this 0.28. That's, and 3 significant pairs, that's 0.280. So that's kind of fine. I don't think anyone is going to have issues with that. We can even check. Let's check this one. So I gave 0.28, so that's within range. That's fair enough. I gave 120. That's also fair enough. That's within the range. Use the information in the table to suggest why it is difficult to predict the relative thermal conductivity of potassium. So you can't predict the thermal conductivity because there is no trend. It was higher, it was 84, then it increased, then it decreased. So you're not sure, there is no trend in the values. So no trend shown by the values. By the values in the table. So no trend being shown. Next one is sodium reacts with oxygen to produce sodium oxide. So they've pretty much given all the information. Sodium reacts with oxygen. Remember, oxygen is diatomic, so it's going to be Na2 and O. Double this because there are two oxygens over here, so there would be 4 sodium. So now this equation is correct. What type of oxide, acidic or basic, or no, it's a metal oxide. Metal oxides are always, and it's a group 1 metal oxides. Those are the strongest bases. So metal oxides are basic. And reason? Because it's a metal oxide. I think that's, hopefully that would be acceptable. Uh, or we can say maybe there could be another reason that sodium oxide, if you dissolve it in water, it gives a pH, it gives an alkaline solution, or it forms sodium hydroxide. Uh, but let's have a look at the. So they didn't give much of a. Oh, they did sodium as a metal. That's fine. So we said sodium oxide is a metal oxide. So that's fair enough. We've pretty much we've nailed the answer. This one we've correctly identified the answer. Let's move to the next part, part C. Explain in terms of ease of formation of ions why copper does not react with sodium sulfate. Now, this is not the answer, but less reactive cannot displace a more reactive. So less reactive cannot displace a more reactive. Now you have copper, which is less reactive, doesn't like to lose electrons. A less reactive metal is the one that doesn't like to lose electrons. So sodium sulfate has sodium ions. It has to give this electrons, only then the reaction would be possible. Displacement reaction or redox reaction would only be possible if copper metal ends up losing electrons to sodium ions, which is not going to happen in this case because copper doesn't like to lose electrons. So we're running out of time. I'm going to continue with this paper. Hopefully, I'm going to early in the morning. I'm going to make a part 2. So I'm going to make another video on this, and we're going to complete this paper. So take care, everyone. Good night. Allah Hafiz.